Good morning and welcome to the webinar, The Manufacture of High Efficiency Coils with MicroGroove Copper Tubes. This event, brought to you by Appliance Design, is sponsored by Copper Alliance. I'm your moderator, Daryl Sealand, Editorial Director for Appliance Design. Thanks for joining us. Today's presenter is Brian McConnell, President and Chief Operating Officer of Burr Oak Tool, Inc. Brian was appointed this position in 2006, bringing more than 25 years of HVAC industry experience to us today. Before we begin the presentation, I want to provide you with a few housekeeping items. At the bottom of your screen, you will see a taskbar. Each icon on the taskbar is assigned to a particular element of today's webinar. If you are unsure about what an icon does, hover over the icon with your mouse, and a box will pop up that tells you the function. A copy of today's presentation is located in the handouts icon. Please take our survey following the webinar by clicking on the survey icon in the taskbar. Below the presenter photo, there is a blank questions box that allows you to type a question in the box and then hit the submit button to send it to us. Throughout the program, Brian will address as many questions as possible, so please submit your questions at any time during his presentation. Today's event is being recorded and archived on appliancedesign.com. All registered participants will receive an email within 1 to 2 business days that has a link to view a recording of this event. And now I'm excited to turn it over to today's presenter, Brian McConnell.
Thank you, Daryl. Welcome, everybody, to this presentation on the manufacture of high-efficiency coils and MicroGroove tubes. My goal is to value everybody's time. I know it's valuable, so our goal is to make sure that you get some value out of this presentation. So let's start. Our first, in a very basic concept, is looking at MicroGroove, or the smaller tube diameter, is to make the coil more efficient. And what does that mean? Really what we're talking about is taking a smaller coil, envelope size, and getting the same capacity as a larger coil. So we believe that looking at the MicroGroove, we can do that. And one of the basics reasons is the heat utilization of the fin, and we've got that illustrated in our first slide. On the 3/8 side, and the left side is the 3/8, you can see we've got a larger pattern, bigger hole. And you can see the airflow. As you condense that with smaller tube diameters, you can see that we're using the fin more efficiently. This allows us to downsize the coil and make it smaller, which would clearly give you reduced material costs and would significantly reduce the amount of charge you would need in that system. So those are two significant advantages and we do believe we get better mixing of refrigeration. Through our conversations with many manufacturers, we've come up with kind of a common questions or unknowns. So I'd like to go over those now. And the questions we get is, okay, how much would be my initial investment outlay? How quickly can I build this thing up and get economies of scale so I can start pricing this thing right or looking at the cost? It's a change in my process, right? Going smaller is a little different, so is the innovation up to par? How much does it actually change my processes? What are the unknowns? What are the difficulties? What are the challenges to manufacturing as opposed to the larger diameter? So we have a questionnaire here. Okay. We're asking kind of what is your concerns in moving to small diameter? Initial investment, cost outlay, the lack of time-tested technology innovation in this area, manufacturing processes, lack of demand from the customer base, material supplier not ready for production, or I'm already producing. Smaller coils, smaller diameter coil. So what we're seeing here is the majority of our respondents are saying indicating that 40% are saying it's the manufacturing process changes. What's going on there? I'd like to understand that better. And of course, we've got about 19% saying that one of the concerns they might have would be the lack of time-tested technology or innovation in this area. And then initial investment is also, those are the top three. What's going to be the initial cost and outlay of the investment? Okay, so the way we'd like to approach this presentation is to really address, seek an understanding of how do we balance the capacity and flexibility and the economics of our investments. How can the material costs be lowered using this familiar or similar process? How can I increase my throughput using automations or higher volumes? And what's on the horizon, looking out into the future of how we're going to approach these MicroGroove coils. We do have a key, if you'll notice on the bottom of those. So you'll see those in our slides. We're trying to present, okay, here's slides where we feel we're addressing the capacity issue, or the flexibility issue, the investment, the material cost, and increased throughput. So that would be, I think, help guide you through these slides. I guess the first place we'd like to start is look at the tubing. Obviously, this is not totally new technology in regard to putting a MicroGroove in the idea of the tube, which disrupts the boundary layers, which we believe, I think it's been documented that this increases the heat transfer of the coil. We believe that intensifies as you get smaller in diameter, that effect. So there's an advantage. Now this, if you look at the slide on the left, we could be looking more at the fluid side or the evaporator side. But there also is an advantage on the condenser side. And what we're trying to get is annular flow as much as we can get through the tubing. And we can see the two pictures here. We've got kind of a smooth wall illustrating, smooth wall, and we're condensing and pooling at the bottom of the tube. We don't want that. What we want that is more distributed throughout the tube. And if you look at the right side, the right picture, we've got internally grooved tubing, and you can see that it's a lot more distributed. Now we believe that effect actually improves somewhat the smaller the tube diameter. So we believe there's going to be two benefits on the evaporator, on the fluid side and on the gas side. Let's talk a little bit about the challenges. Obviously, if you're used to working with larger diameter holes in your coils, 3/8 per se, going to something smaller, 7 millimeter and 5 millimeter, it's the same process, but it also presents some challenges because things just need to be a little cleaner, a little tighter, a little more robust. And I think the best way to phrase it is the attention to detail. Okay, things have to be right to get the right outcome, and that includes stamping the fin, bending the tubes, and probably even more important, the expansion process. That process gets more robust. So let's step through that. We do believe we have some opportunities coming in the recent future in regard to a process by which the expansion of a copper, this MicroGroove copper tube, can be done with a non-invasive. Non-invasive means we're not going to take a bullet down the ID of that tube, and we're going to leave the ID of the tube in its native state. We're not going to be deforming anything. And we believe that there's going to be some opportunities to kind of understand and develop whether it's the performance benefits of that, and also maybe redesign an internal groove to help us with even improve the annual flow even more and increase the efficiency of the coil. Here we'd really like to have a conversation and look at the MicroGroove versus the microchannel. Our experience is when we have conversations about microchannel, a lot of the comparisons are typically in regard to a 3/8 tube coil. And we believe in today's state, that's probably not a fair analysis. So what we'd like to do is balance that a little bit and change the conversation somewhat and compare and contrast. What we look is there's some design inflexibility with the microchannel, meaning the single pass fluid. They're obviously changing that and reconfiguring that is obviously a lot more difficult. It does have challenges with corrosion and useful life. If you're looking at manufacturing these coils in your facility, obviously the initial costs are going to be very high, and there is operational costs ongoing that are high also. And the other, I guess the point we try to make in this conversation is we've seen a lot of analysis of 3/8 coils in the microchannel, but let's look at a 5mm coil in regard to a microchannel. So we did a study, and we took a microchannel coil of a certain face volume, and we took a 5mm coil with the same area. And we do have a slide that kind of lays out all the details here in the back that you can review at some point. A lot of detail on there. So what we found is when we took the same flow rates of both the fluid and the air side of both coils, we found that the 5mm coil was 8% more efficient. Now that was obviously interesting. Then we said, okay, so how can we can make the increased efficiency of the 5mm coil by increasing the airflow, the flow on the air side, and also on the refrigerant side. So we were able to do that, increase both of them. We could not do that on the microchannel coil because of the significant back pressure of the microchannels. So basically, that was the results you were going to get. When we increased the flow on the 5mm coil, we found a 48% increase in its efficiency. And that would, so obviously it was already more efficient than the microchannel. So we went even up, so it's almost a 60% improvement in efficiency or capacity with the same coil face. So we believe that should plant a seed as, hey, let's understand that better, and maybe we should investigate that a little more. So obviously we think that would have system-wide advantages because your tube's not as long. You're going to get less back pressure. There also is a penalty, a back pressure penalty for in putting the internal groove in the tubing. But as you go smaller in diameter, that penalty decreases. So there's another advantage of going to the microchannel. Now let's kind of pivot a little bit and look at, we've got some illustrations of kind of the flow distribution or the maldistribution. On the three pictures on the left, we've kind of laid out an heat imagery of 3 microchannel coils. And you can see we've got hot and cold spots. Trying to avoid that because that hurts the efficiency of your system. You can see we've got different orientations, and that's done to try to manage the condensate, which is another issue that the microchannel has is dispensing of the condensate. So sometimes we change that orientation. So you can see some are better than others, but we still have some maldistribution issues, which is hurting our coil efficiency. On the furthest to the right, we've got a round tube. And you can see, obviously, it's got a better profile. And there again, we have more design flexibility because we can change that circuitry to if we do have we've got a maldistribution problem, we can address very easily and flexibly that circuitry to address that. It's much more problematic with the microchannel approach. We'd like to take an opportunity to ask some more poll questions. If the decision was made to transition, what would be the earliest time that your organization would adopt small diameter? You got 1 to 12 months, 13 to 24, to 5 years or greater. So the respondents, we're hearing about 47% this month, 52 is saying 13 to 24 months. That's kind of what we're looking at. That's obviously going to be and then 2 to 5 years would be about 25%. And then we got 10% saying they're already in small diameter production. Okay, so let's talk about the manufacturing process of small diameter or MicroGroove coils. We've obviously got fin stamping, the collection, the bending and handling, and the coil expansion. Let's talk about the fin stamping. We've got two things coming together within the industry. If you go with a smaller hole, that obviously provides a smaller pattern, which obviously means in the same die space or press space that we have, we put more holes. If we put more holes, that's obviously an increased tonnage, and we're doing more forming. At the same time, the industry is going to a harder fin stock for material handling benefits. This also increases the tonnage requirements of this die. So we've got two things coming together. So when we're looking at this, we've got to make sure that we have a platform that will support that increased tonnage. And therefore, calculating the tonnage of the dies, especially if you have existing equipment and you're going to integrate some of this, you've got to be very careful to make sure you've given some thought to what is the tonnage of that die and is it going to be proper for that press. A lot of times we have found that that conversation doesn't always happen, and it's kind of after the thought when we see where in the mechanisms of the press, and we say, well, why am I replacing these bearings every year, and I never used to have a problem? So that's really one thing to kind of make sure you understand, or at least ask the proper questions. As I stated earlier, the smaller the hole gets, the more problematic it becomes handling these fins. And handling, I mean organizing or stacking. It requires a lot more precision in the stacking mechanism, your approach to the rods, how you're moving those fins on and off the rods. And also the other thing with the MicroGroove or these smaller coils is we're seeing that the fin density is increasing, which also increases the weight on the stacker. So there again, when you're talking about integrating or retrofitting or putting equipment together, that is something to be very careful and thoughtful and think through. Okay, is my original equipment capable of stacking, maintaining, and organizing these fins? You know, it's been challenging because of these smaller holes, getting them, processed through the die and line and dropped on the stacker rods. So really what we're looking at is a way to kind of change that and organize these and stack them without rods. And that would give us some more of a continuous flow of these fins, which we believe would help your throughput. Also, obviously the smaller tube diameter becomes critical when you're processing the tube itself. If you look at it, it's not quite as, looking at it as far as longitudinally, quite as rigid as a 3/8. So processing that through the bending process becomes a little more difficult. So again, you have to take the right approach. And a lot of times with existing feeding mechanisms with older equipment, the amount of pressure it takes to move that tube forward tends to not work well. It crushes the tube. So you kind of have to look at how you're going to feed that thing forward. We have also addressed this too in how we're straightening. We don't use rollers because there's a lot of work hardening and adjustments. We're using stretch straightening, which we believe gives a more consistent. You're not getting work hardening spot, and the tube's a little more consistent, which would be beneficial in the expansion process. Therefore, we're looking for consistency. Okay. We have a question.
Yes, looks like we have a question from David Radiloff who says, what about coil payoff issues? Can MicroGroove be handled in conventional level wound coils? Can it be processed with eye-to-sky payoff out of convention coils? Can it pay off eye-to-sky from large bulk coils such as coil in a box?
I guess the answer is yes to all those. Now, what we're seeing most of it is the bulk, right? Because that obviously reduces the amount of lacing, the time you're lacing the coils. So what we're seeing is it's eye in the sky. Most of the coil stands are eye in the sky, and we're doing the bulk, or we're getting as big coil as possible behind that coil stand. So yes, you can do it either way, but we obviously would recommend the larger eye in the sky pulling out the bulk. Is there another question? Okay. Go back. Okay, so we're saying is we kind of changed our approach to how we're bending this thing. Another thing, as I mentioned, this tube's not quite as stiff longitudinally, so we've changed how we process it because the rod, the mandrel rod, gets smaller also, which is problematic. Any interference in that tube whatsoever will disrupt and bend these rods. So we've kind of changed how the tooling goes, so the rod is more contained and they can't bend, which is going to increase your uptime. And part of that process of bending, we've changed the process of bending. It's not your conventional, it's a different methodology, which we have found has produced, has really minimized the peg leg. We're getting a lot more consistency in regard to the peg leg and the consistency of the leg. This is very important in the expansion process because one of the most challenging things to do in this process with the MicroGroove or smaller tube is that final expansion process where we put that bell and cup. There are other issues, but that seems to be the most challenging. So getting this closer and tighter as far as the leg length is very critical. And it requires a different methodology to how you're going to process through this machine. And this also has a productivity improvement. And we could make that same comment as far as these fin lines. We're being able to put more patterns and holes per fin line. So as you're scaling up to a larger volume, you might only have to, we have to look at the details, but you might have to buy 2 fin lines instead of 3 or 4. You might need 3 hairpin benders or Triumph benders instead of 4 or 5. So we believe there's going to be some economical payback for that for reducing the capital investment. Okay, as we were talking previously, probably the most difficult or challenging change in the process for the small tube has been the expansion process. You've got a couple things coming together here. If you look at that smaller diameter, it has as you decrease the diameter, your hoop strength increases. And really what we're trying to do with this expansion process is push that diameter out. So now you've got a tube that's probably not as tough longitudinally, plus it's harder to move out radially. So you got 2 things coming together, which really makes it a challenge. For small coils, and I'm going to say 1 meter or less, that it's obviously a lot more manageable. As you get that 2 meter or even longer, then you have to really start thinking, okay, how do I approach this? And so what we've done is we've got some conventional technologies. It's a mechanical approach with a rod and bullet. What we've done is guided it, and you have to have this thing really organized. You can't have any spaces to where the coil is unsupported, especially for single row. they tend to want to collapse. So what you really have to do is guide and support it. And there again, you've got to, we think that this does alter the internal groove of the tube somewhat also. So we believe that it's doable, but there again, a lot of care has got to be taken. It's got to be set up right and has to be maintained. And there probably is going to be some training and say, okay, here's the approach, and here's how we've got to guide this thing and capture it. What's coming down the road in regard to that expansion is we're looking at a process that doesn't have a bullet. So we're going to expand the ID. We're going to expand the ID and OD into the fin pack, and not contacting the internal ID of the tubing. Now, again, this will give us a zero shrink, which is going to be material savings, up to 3 to 5%, depending on what you're currently getting. Significantly smaller floor plan layout on this type of equipment. And also there again, I think there's going to be some economies as far as one machine might outproduce two of our vertical because of the increased throughput. And there again, also we're looking at changing how we're processing that final expand to do that bell and cup. So rather than trying to do it all at once, we're going to segment it, and we've got a methodology we're using to accommodate if you do have some peg leg or some different inactives coming in your coil, a way to accommodate that in the process. That will be very significant because that right there is one of the most difficult things to do with the MicroGroove is that last final process where you put the bell and flip. Okay, so that's our presentation on the MicroGroove and high efficiency coils. Do we have any, and this would take some opportunity to answer some questions. Anybody has any?
Yes, absolutely. Brian, the first question is going to be, what do you view as the greatest challenge for Burr Oak Tool as a machine supplier in the coming years?
So that's a good question. Really, our biggest challenge is, I think, is really getting a process, a whole process from the coil manufacturing for this MicroGroove to getting one that's more robust and is going to get consistent output. We've got some pieces together, and we've got some things that are working, but we need to do kind of an integrated thing and saying, okay, here's a turnkey and something that's robust, and you can produce a consistent high volume.
Okay, great. Next question. How quickly do you see small diameter coils being the norm in applicable heat exchange units in the future?
How quickly? My view is that's probably going to be, I would put that in a 2 to 4 year range, I think. And most of that's going to be driven, I would think, by the material cost savings, especially when we start getting these economies of scale and some production lines, these higher capacities. Obviously, that's going to help some, drive some standard costing down too. So I'm thinking, as things stand today, that 2 to 5 we'd see more and more of that going to this MicroGroove.
Okay. Next question. Of the methods that you mentioned in your presentation, which process do you anticipate being the hardest for the industry to innovate to meet demands of small diameter production?
That's a good question. Repeat that, would you?
Of the methods, yeah, which is going to be the hardest to innovate for small diameter?
I think it's going to be that expansion process. If you look at it as far as us, it's going to be taking care of that expansion process. And I guess I wouldn't comment on the design side, but as far as the manufacturing, and also I also think handling of the fins. right? I mean, because your fin's getting smaller, the fin pack density's up, and I think the two things, I put them in parallel, the handling of the fin, how are we going to organize that? How are we going to make that easier? Because right now, the standard process of dropping on a rod, pulling it off, laying it down horizontally, and organizing it and lacing it is cumbersome. So we really need to take a look and say, okay, how does that look different? And I think that would also provide some labor savings.
Okay, great. Just want to give it a couple seconds here to see if there are any last extraneous questions that anybody wants to ask. No, it looks like that was the last one. So I am going to say that this concludes today's webinar. So please join me in thanking. I'm sorry.
Could I add one more thing?
Sure.
Okay. In regard to if somebody wanted some more information on the kind of the advantages of our Triumph fender, we've attached a white paper that has a lot of details in that. Do you have another question?
Okay.
And do we have another question?
Yeah, it does look like we have another question that came in. James Glenn asks, when do you expect the bulletless expansion to be commercially available?
That's a tough one. I think it's really, I'm going to answer it in two phases here. One is if I've got kind of a smaller coil, meaning, I don't know, let's say under a meter or even less than that. I believe that might be available within a year or less. Now, when you do the longer coils, meaning 2 meters, 3 meters, that might be a year plus, because we've got some things to kind of work out there. And we've got the process of how it works on the smaller coils and translate to the longer ones. So.
Okay, great.
All right, thank you.
Oh, is there anything else you wanted to add, Brian?
No, thank you very much for your time. I appreciate your time and attention.
Awesome. Okay, so again, please join me in thanking Brian McConnell for his presentation, as well as our sponsor, Copper Alliance. Be sure to visit all of us at AHR next week in Burr Oak Tools booth number 4248, the Copper Appliance booth number 1156, and the Appliance Design booth at number 4440. As you exit today's webinar, please take a couple of minutes to complete our survey. We strongly welcome your detailed comments to help us serve you better. If you have any additional questions or comments, please don't hesitate to contact webinars at bnpmedia.com. Please visit webinars.appliancedesign.com for the archive of this presentation, as well as information about upcoming events. We appreciate your time and hope you found this webinar to be a valuable experience.